Evening to us. So my name is Isaac Ananemankwa, and I'm a backend engineer currently with Enyata Ghana. Yeah, that's where I'm working now. That's a bit of me. I do also front end, and so I would say I'm a full stack developer, but in professional world, I'm concentrating on the back end. Okay, so that's a bit about me. So yeah, we have limited time, so let's get started. I don't know if anyone wants to ask a question about myself. If you have, you can ask before we start. Yeah. So if you have a question, you can unmute your microphone and ask. All right. I will take that as a no answer, a no question.
Yeah, so you can go ahead.
All right, thank you. So yeah, we are going to talk about asynchronous JavaScript today, and I want the session to be very interactive. The reason being that I believe discussing the topic makes it we get to understand it very well when we discuss. So even though I'm leading the discussion, I'm also learning, and so I want us to discuss. In that way, if you have any question or contribution, it's easier for you to bring it out. I always say that talking about your problems in class is better than going out with a problem and then going around asking other people. Plus, you have a community like this to ask from. Also, when you ask the question here and you get the answer here, it helps your other colleagues. It helps us all to also understand it very well. So if you have any question, please don't hesitate. Just alert us. We will give you the opportunity to ask, and then we will also try to. When I say we, I mean all of us. We come together and then help you because I'm also part of you. Okay. Uh, so I'll share my screen a bit. Kindly hold on for me. I'm preparing my PC to join you. So kindly hold on for me.
Oh, hello, Isaac. Are you still on the call?
Yes, please. I'm still on the call.
Oh, all right. Okay. Okay. Hello, guys. Let's just give Isaac a bit of time.
I'm almost done. Okay. All right. All right. So as I'm preparing to join, uh, have we heard of asynchronous JavaScript before or asynchronous as in general? Anyone to help us with asynchronous? Anyhow you want to help us with explanation? Hello.
Hello, can I go ahead with it?
Sure, you can.
So asynchronous, probably from what I've heard about it before, is just about ensuring that something is done before going ahead to the next stage. Like you have to complete stage one before going to stage two. So asynchronous is a way of ensuring that our programs run without having to wait for a part of our code to finish running when the machine can actually run some other part that are not independent, that are not dependent on that aspect.
Hello, Isaac, are you still here?
Sorry, I will mute myself. Okay. So yeah, I was saying you are not far from right. And you are not wrong. Yeah, that's very impressive. I want at least two other inputs and then we can continue. So anyone else? Asynchronous.
All right. Can you hear me, please?
Sure.
Okay. So asynchronous operations, or let's say asynchronous programming generally, refers to operations that allows a seemingly very long operation or potentially long operation to start, to commence. Then the machine can attend to other events. Then when that operation is done, the result can then be presented.
Okay, that's nice. Last person. I think this class will be interesting. I like what I'm hearing. Last person. Anyone else?
I don't think there's anyone else that wants to go.
All right, that's fine. So yeah, what you all said, you're all right. You're all right. Yeah, I think you've tweeted MongoDB, right?
Yes.
Okay. Yeah. So I think that will make it easier for me when it comes to the explanation. So let me go ahead and share my screen and then so that you understand what I'm talking about. Okay, share screen. Please, can you see my screen?
Yes.
Okay. I hope you can still see my screen.
Yes.
All right. So straight into today's business. Now, I am sure you are already familiar with JavaScript because you are treating Node.js, and so you know what JavaScript is. So I wouldn't spend much time explaining JavaScript. And with asynchronous too, you've already told us what asynchronous is. So when we combine these two words, then we get to a point where we know that in the operation of JavaScript, how JavaScript runs as a program, there is one architecture, one style of running a program that is asynchronous. And that is, in other way, okay, before I explain this, so let me go back to the opposite of that. That's synchronous. When we say synchronous, in other ways, we can say blocking. Okay, what we mean by blocking is that before one, how we write our code runs from top to down. So what is down would have to wait for the ones on top to run first before they can also run. So we say the code on top. Let's say we have code on line 1. Let me try and then also let me add them. Okay. I'm trying to open my VS Code so that okay. All right. Please, can you see my VS Code?
No, we can't. We're just seeing your docs presentation.
Oh, okay. Let me. Okay, I'm trying to share my entire desktop. And so I'm so sorry about this. Okay. Okay, so let me stop sharing here. And okay. Okay. So please, can you see my screen now?
Not yet.
Yes.
Which screen are you seeing now, please?
I'm seeing your home screen. Okay, now there's something like a code. Now, wallpaper, asynchronous JavaScript.
Oh, okay. Okay, so you can see my VS Code now, right?
Yes, we can.
Okay, that's great. All right. So I can share now. Okay. So I'll go ahead and then create one file in here. I'll create an index.js file. I just want to demonstrate the difference between the synchronous and the synchronous, and then we will get back to what I was talking about, what we are going to do for today. So when we talk about synchronous, I'm going to demonstrate that with 2 examples. So I'll start with console.log, and then I'll say before. Okay. And then I'll come down here and then I'll do another console.log, and then I would say after. Okay. Then I'll go ahead and then run this. So I'll just bring my console and then I'll run this with node. So I'll say node x.js. So let's see what happens in the console. You see, we have before and then after. Okay, what is happening? This line 1 has to run before line 2 would have to run. There is no way line 2 would come first before line 1 comes. So line 1 is blocking line 2. Until line 1 is successful, it's done processing. It will not move to line 2. That is synchronous. That is what we term blocking. Okay, and the opposite of this is asynchronous. Someone will ask why the need for this particular thing. I'm going to demonstrate the asynchronous also to you, but I want to explain the reason why we need asynchronous programming style in our work. Now, imagine we have a program. We are trying to serve other clients. What I mean by clients, so a perfect example is Facebook. Okay, and then there is one server serving all the users on Facebook, and then person A logs in. At that moment, the server is serving that particular client. If another client comes in and wants to log in, because it's just one process, the server the other client has to wait for the first client to be to finish up with his styles before he can also come in, because it can't handle multiple requests at the same time. It can't do so many other things at the same time. Okay, yeah, that is one example. And then I want to also state, I'm going to be a bit technical at this point. Deep down within the CPU of the computer, I'm not teaching hardware, so I will not go deep, but I'm just trying to let you understand. There's something called a thread in the CPU. Okay, that's the processor. There's something called a thread. There are some of them, some programs, they work on a multi-thread. It's just like number of ways you can process a particular task. Okay, think of it that way. The number of ways you can process a task. So if there are multiple tasks and then there is a multi-thread, that means different threads can work on different tasks at the same time. But when it comes to JavaScript, there is only one thread. It's single-threaded. Okay, by default, JavaScript is single-threaded, so you can't handle multiple tasks at the same time. And with that, in that case, it will render your system slow. A typical example is what we have on the screen now. What if we want to display before and after at the same time? Then we can't do that because the first line would block the second line. Another example, we are working in a real world app like Facebook, where our users have to log in or they have to create an account, or we want to log in. The process of logging in, you have to access the database and fetch the user. So the user will input the username or email and then the password. You have to fetch from the DB and compare both the username and then the password the user inputs to the one in the database already. If they match, then you grant the person access to the app or the system. That process where you fetch data from the database, the database is also on a different platform, or it's also somewhere else. You have to access it. It's somewhere on another computer, another server. You don't know when the results will be returned to you. And so if you decide to wait for that process, then the whole login process is going to be delayed. That is synchronous. But with the help of asynchronous programming style, we can fetch the DB details without waiting for it, and then we can release the single thread to do other things. So I've come back to the thread thing. So we have multi-threading and we have single threading. JavaScript is single threaded. That's it. All the processes that goes on in JavaScript is handled by a single thread. So in order to make it efficient, to make that single thread efficient, you need to write your code in a synchronous style so that once your app is working or your system is working on one request and another request comes in, to be able to release the main thread, the thread to handle other requests. When the resource is ready, it will handle that request as well. I want to stop here, pause here, and then allow for questions before I explain other styles. Anyone with any question?
Clear from here.
All right, that's okay. So I'm going to demonstrate the asynchronous style to you as well, and then we can apply it practically so we understand. There is a common function or method in JavaScript. I'm sure most of us, we are aware of the set timeouts function, this particular function. Okay, in this function, it takes a function as its first argument. I prefer to use the arrow functions. And then it takes timeouts, the number of the milliseconds we want to wait before our program or our block of code runs. Okay, so here we're going to say 2000 milliseconds, that is 2 seconds. Okay, and then what we want to run after 2 seconds, we put that in this block of code, this block, function block. So we're going to say console.log, so I'll say processing information. Okay, so those of us who are not aware of this particular set timeout function, let me space it out so that we are clear of that. This set timeout function, it says, I want to run this line of code. That is that particular function. It's called, and it's an anonymous function. I'm sure you are aware of that. It's a function. So I want to run this function, but I don't want to run it now. I want to wait and run it after 2 seconds. Okay, and that is what this means. So you wait for 2 seconds and then it will run this line of code. But don't forget that I stated earlier on that by default JavaScript is synchronous. That means if we are saying we want to delay this particular process, the second part, for 2 seconds, that means this after would have to wait for that 2 seconds. Once this is done, and then it will move on to the after. But with the help of this set timeout, we delay 2 seconds, and then the synchronous nature of this particular function, it will skip this line. What I mean by skip, that I'm not saying it's not going to work on it. It is going to skip and move on to this line, and then allow this process to be handled by somewhere else. Once it's done, it will return the results to us. Let me run this code and then you see that in action. So I'll clear this, my console, so that we see what I'm talking. So I'm going to run. So now let's see. Now we see before, after 2 seconds, and then we see processing information. I'm going to do that again. I'll clear my console and then I'm going to run again. So before, after, and then after 2 seconds, you see processing information. Even though we have processing information in the order that we've written our code, that's the second item to be run. But since we are waiting for 2 seconds, JavaScript or Node.js automatically moves to the next item and process it, waiting for that particular process to complete and then get the results from there. And then it will give us the results. That's the beauty of asynchronous architecture. We don't have to wait for some process to finish before we can go on with our main thing. So we need the results of that operation, but we still have to handle other stuff. So we can give it to the asynchronous, we can make it asynchronous, then move on with our normal processes. Once it's ready, it's going to return the results to us. How it does that, we are going to talk about that. But before then, do we understand? So this is asynchronous. This particular function it's in itself asynchronous. Any question, or we are good to go?
Okay, sir. If I can get you very well, the function itself, set timeout, is the asynchronous operation. So even if we put 0 seconds there, we are still going to get processing information last. Is that correct?
Yeah. So if we put 0 here, that means we are waiting for 0 seconds. So let's see that in action. I'm going to run it again. So I'm going to clear my console. So what we are doing now, we are trying to simulate how a synchronous architecture works. Okay, it's a simulation of how it works. So even though it's 0 seconds, but it's coming last because we are waiting.
I understand. I get it now.
I don't know if that's clear.
So, Green, can you answer so that you'll be sure that it's clear?
Yeah, I said it's
Please. I want to ask if the second, is it really seconds or milliseconds?
I think your line is not clear. I don't know.
I mean, the number of seconds we are indicating after the console.log. So is it in seconds or milliseconds?
Oh, so when we say 2000, it's milliseconds. So 2000 milliseconds.
Okay, all right. Thank you.
Yeah, 2000 milliseconds, which is equal to 2 seconds. Can we continue? Can we all see my screen? I'm sharing my slides now. Can we see that?
Yes.
Yeah.
All right. So that's an introduction of it. I think that's the first one we've talked about, synchronous versus asynchronous code. So we're going to talk about the patterns for dealing with asynchronous code. There are 3 patterns, popular patterns that we deal with asynchronous code. If you want to write your code using the asynchronous style or architecture, there are 3 ways you can do that. We're going to look at 3 of them and look at the efficient one. I am someone that I advocate for clean code. It's good you write clean code so that other developers will pick your code and then they will also understand easily, read it easily. It makes sense easily. Yeah. So we're going to look at these 3 patterns, and then we'll pick the efficient one or the cleanest one of them among them, and then we're going to stick to that. Yeah. So we're going to talk about them. We have callbacks. That is one.
Isaac, can't hear you. You're muted.
Sorry. So we're going to talk about callbacks, and then the introduction of callback is going to introduce another thing called callback hell. And then, so it's a problem that comes with callback. So we're going to solve that using named functions. And then we see the problem callback comes with, and then we solve it with promises. Promises is also another pattern for dealing with asynchronous code. So we're going to talk about promises, and then we're going to replace the callbacks with promises. We talk about how to consume promises and creating settled promises, running promises in parallel, and then finally talk about async and then await. Those of us who have not heard of these terms before, they'll be then, is this guy talking about? Don't worry. By the time we close, I'm sure you'll be very okay with everything we're going to talk about. Okay, so video. Okay, so synchronous versus asynchronous. We're saying that synchronous tasks are performed one at a time. Okay, one at a time. And we've demonstrated that asynchronous code operations can move to another task before the previous one finishes. We've demonstrated that, and so I'm sure with this part we don't have any confusion here. Now, Node.js. Recently, I was reading an article. I think the article is old, but I was reading it recently. PayPal, initially they were using Java to handle their operations, and then after the introduction of Node.js, they ditched Java, and then they picked Node.js. I was asking myself why, because I know Java to be a very fast program. And then reading the statistics they posted, I realized that when it comes to data-intensive apps and then real-time apps, using Node.js is very important, and that is due to the asynchronous nature of Node.js. Okay, so building your apps with Node.js, and then once the app or the system is data intensive, or what we mean by data intensive is that you're going to access the disk more. It's more of file system type of software you're trying to build. You're going to use the disk more, hard disk, access drives. Then Node.js is you're in a good position to use Node.js. And then also when you're working with real-time apps like chat systems and stuff, then Node.js is also good because of its asynchronous nature. Because you can handle multiple requests at the same time. While someone is sending a message, you don't have to wait for that message to come. You can also send your message at the same time. And that's due to the synchronous nature of it. And that is why it is really good to use Node.js for data intensive and real-time apps. It also is scalable. It's scalable due to its asynchronous nature. You can scale up anytime you want to without causing any problems. And that is due to the asynchronous nature of Node.js. Yeah, so I mentioned that I will explain to you how Node.js, even though it's single-threaded, it's able to handle the it's able to handle multiple requests. Now, I'm going to use this metaphor to explain how Node.js works, and this is the synchronous architecture of Node.js. Okay, so think of your program or your system as a restaurant. Okay, so in a restaurant, we have a waiter or a waitress. Anyway, a waiter or a waitress whose job is to serve the people there. And then, so in here, we have a waiter, this yellow circle, that's the waiter. We have 2 tables here. So we are going to, this is going to depict the customers coming in to buy food. And then we have a kitchen, that's where we prepare the food. Okay, so this is what happens in the asynchronous architecture world. There is only one waiter in that restaurant. And this time, this waiter is our thread, a single thread. There is only one waiter. And what happens is that this waiter, once you enter and then you sit by your table, this waiter will come to you and say, hello, what may I offer you? Then you pick your menu, select what you want. This waiter will just pick your order, send it to the kitchen and tell them, hey, table 1 has ordered for this, so and so. After the waiter has delivered your order or asked them to prepare your order, he or she does not wait in the kitchen for your food. The waiter will leave the kitchen and move to the next table if someone is there, take the order and send it back. So if there are 100 tables there, the waiter will go take your order and send it to the kitchen, just like that. The waiter will not wait for the food to be prepared before he or she moves it to the table, brings it back to you. And then, so the moment the food is ready, the kitchen will let the waiter, hey, we are ready. Then the waiter will come back, get the food, and then serve the table that the food belongs to. Okay, so think of asynchronous architecture as a restaurant with only one waiter. Then the waiter will then move from table to table, taking the order. And then once it's ready, the kitchen will let the waiter will come for the food and then serve. In asynchronous architecture, that's the opposite of asynchronous. We have multiple waiters or waitresses. So at any point in time, there is a waiter standing somewhere waiting for someone to come in to place an order. So that if there are multiple waitresses or waiters, then the waiter can take your order, go to the kitchen and sit there and wait for your food to be prepared, and then we'll take it back to you. The problem with that style is that we are not being economical. We are not making use of our resources. It's costly. While you can use only one waiter, some of these, this is too, no, we are not, these are not human beings. They are computers, and they've been built to be able to work that way. So in order to be economical and less costly, then why don't I go for one waiter, and that waiter is going to do it efficiently? Okay, so that just a single waiter will take care of all the tables instead of going in for multiple waiters or waitresses. So to bring that into light, as in programming style, let's, from this same example, I'm going to use technical terms now. So think of the tables as requests. So here we had table 1, table 2, and a waiter, and then a kitchen. Okay. In here we have request, 2 requests. So we had table 1, table. Now we have request 1, request 2, and then we had a waiter. Okay. Now we have the thread, single thread. We had a kitchen. In here we have an event queue. So this is what happens. A request comes in, then the thread will receive the request. Okay, and then place it in the event queue. Then that's where the action takes place, the event queue. Okay, it takes place. Once the process is ready, it returns with the result. The event queue just alerts the thread, hey, your request is, the thing you requested for is ready, take it. The thread will grab it and then pass the request back to the one who made the request. At that same time, the thread is not resting. The thread is still moving within the program, looking for requests. Once it gets a request, it sends to the event queue. And once the event queue processes the request, it sends it back to the thread, and the thread releases the results. So that is a synchronous architecture. So there is no time for delay when it comes to synchronous architecture, and it's very efficient. Any question before we continue? The asynchronous architecture, are we okay?
Let's continue.
Okay. So I've already mentioned that Node is ideal for building applications that include a lot of disk access and then network access. So when you're going to access the network, okay, you're going online, you're going to fetch something from online. So in JavaScript, there is a popular, one of the APIs in there, the fetch API. If you want to fetch data or make a request somewhere, sometimes you want to place a request to another server. You don't know the runtime of that server, and so it might delay. That is when the synchronous style comes. You have to wait for that resource. Okay, that is one. Disk access. If your disk is running slow, you have to wait for the results, and so you need to write your programs in a synchronous architecture or style. All right. So I mentioned that we have 3 patterns for dealing with asynchronous code. Then I mentioned callbacks. I mentioned promises, and then I also mentioned async and await. So callbacks, that is the traditional way for dealing with asynchronous architecture. And that is, a typical example is this particular set timeout function, okay? We are going to go into details how callback work. And then we have promises. Promises is more of, it's a build up of callbacks, and it's cleaner compared to callbacks. Then we have async await, which was recently introduced into JavaScript. That is 2015. Yeah, the ES6. It was introduced in there. It's just a syntactic sugar around promises, but it's way cleaner. Async await lets you write your code as if you are working in a synchronous environment, but under the hood, it runs your program asynchronously. That is async await. It's cleaner, shorter compared to both of them. And so in most cases, you're going to see async await when you pull any Node.js project or JavaScript projects from GitHub and you go through, you realize they're using more of async await than these two, the previous two, callbacks and promises, but they all function the same way. Okay. All right. So enough of the theory. Let's get into VS Code and then play with the code. Before we play with the code, any question?
Question from here.
You have a question?
Oh, no question.
Come again.
I said no question for now.
Oh, okay. All right. Okay. So I'm going to init a new, I'm going to do an npm init. Okay, and then I'll pass the white flag in here. Okay. So that's cool. I have it in here now. Okay. So I want us to take a look at something. Let's say we want to fetch users from a database. Okay, so let me list them down. So we want to fetch users from database. After we've gotten the users, we want to fetch or get their usernames from the data we get from the database. So, and then with the usernames, we are going to, everything we're going to do is a simulation. We're going to fetch the user's GitHub details with the username we get from the database. So GitHub, so we're going to fetch the GitHub profile with username. Okay, and after we've gotten the username, we are going to get all the repos for that user. Okay, so we want to perform this operation. That's how we're going to learn this particular. So we're going to fetch users from the database, fetch their GitHub profile using the name, username, and then we're going to fetch, get all the repos for that particular user. And in this, we want to, it's continuous. Once we get this, then we move on to the next one, and then we move on to the next one. So in an ideal case, how we're going to handle this particular problem is by chaining some functions in order to get our final results. Okay, what I mean by chaining, that is where callbacks come into. Before I talk about callbacks, are we familiar with callbacks, JavaScript callbacks? Are we familiar? If not, so that I can explain. Are we familiar with callbacks? Are we okay with callbacks? Should I explain what a callback is, or we are okay with it?
Hello, guys.
You can just explain a little bit. Actually, I have a knowledge, but
All right, that's fine.
I don't know if we still need.
So that's fine. That's fine. So I'll explain from this angle. You know, we define a function this way. Let me go direct. So I'm defining a function Let me just something. I'm short of ideas. All right, so I'm declaring a function, and then we know that when we can pass parameters to a function. Okay, so maybe we can say, now I have a name. So get some, we are trying to get the sum of two numbers. So we have num1 and then num2. Okay, we call these two variables, we call them parameters. Okay, so at the time we are invoking this function, we need to pass these two, we need to pass two arguments to this particular function. There are some cases that we don't pass only variables. We can pass a function as a parameter to a function. Okay, we can pass a function as a parameter to a function. When we do that, we call that a callback. What it does is that a typical example is what we are doing up here. We want to fetch the GitHub profile. Immediately we get the users from the database. And immediately we get the profile, we want to get the repos from that particular user. Okay, so it's like a chain. Once this is complete, move on to the next item. And that is a perfect time to use callbacks. So it's just like, once you are done, call me back. That's it. So this is the first function. Let me define another function here and say, so I'm going to, instead of num1, I'm going to say callback. It's just a name I'm giving to it. Okay, and then I can say callback, and then I would say console.log. Okay. All right. So I need to define another function in here. Oh. So we are not going to use this num1 for now. Okay, so let me just clear it from here. Okay, so this is a function that takes only one argument. It has only one parameter. It takes one argument. A callback, and I said a callback is a function. So you can pass a function as an argument to another function, and it's called a callback. So this is what I'm going to do. I'm going to invoke this getSum function. Okay, and inside here we need a callback. That is a function. So I'm going to pass this anonymous function to it. Okay, I'm going to pass, let me just close this, pass this anonymous function to it. And then I would say, all right, sorry. Okay. Let me log another thing, console.log. All right, so I've called the function, the getSum function, and I've passed the callback function to it again. And inside here, I'm logging another thing. So let's see what happens. Let's see what happens in the console. Right, again, and then I'll run using this. So let's see what is happening in here. For the first one, we have done with this process, which is this particular function. Okay, that's the function. And then we are seeing the second one, which is getting user data as the second one. The reason why this is happening like this is that this function is called first, and then we are invoking this callback function again in here. So it's going to run this function, and then within this function, there is another console.log, so it's going to run this. So this will run first, and then this will continue. Okay, so to make it clear, I'll take this one off for now. Okay, then I'll run again. So in here, we are not console logging anything. We are just coming up, bringing this function. We are passing it as a parameter, as an argument to this function. But because this function, the callback function we are passing, has the console log in it, it's going to run within the getSum function. Okay, so to make it clear, I'm going to clear this and I'm going to demonstrate with what we have, the problem that I stated up here. So we need to fetch the user data from the database, fetch the GitHub repo, and then get all the repos. Okay, so this is what is going to happen. I'm going to say get user data. Okay, so that's a function. Okay, get user data. Then within this function, okay, I would say just do a console. So I'm simulating that process. Sorry. As I said, it's going to take some time for it to come. So I'm simulating that process. So set timeout. Okay. It's going to take, let's stick to our 2 seconds. And then we will log console.log. I'll say retrieving user data. Okay. And then we're going to return. Okay, so that's fine. So this is the first part of our code. We are fetching the user data. So let's run and then let's see what happens. Okay. So we are waiting for the, sorry, I didn't invoke it, sorry. So I would say get user data, and then that's it. So call it now. Yeah, so after two seconds, it's saying retrieving user data. The next thing that we want to do, we want to fetch the GitHub profile with the username. Okay, so once we get it, then we move on, and then so we don't want the process to end. We just want it to continue. Okay, and so with that, we need to pass the next item or the next function as a parameter, as an argument to this particular get user function, so callback function to it, so that once the process is done, the retrieving data process is done, it's going to call the next function in line. Okay, so I would say I'm going to pass it in here. Okay, and then so in here I'm just going to I'm just returning some data. So I would say return the user data. See. Okay. All right. So returning. All right, that's fine. Okay. Okay, so I'm returning user now. Okay. So let me add the user object here so that we see it in the console. And then, so for now, I just want us to test what I just added. I'm just adding a user object, just like in a real world. So after 2 seconds, we get the user. The user we are getting now is Isaac. So it's okay. So in our console now, we see. Let me clear this thing again. And run. All right. So retrieving user data, and now we have the user data. Okay, ID, then username. I just added it to the console log so that you see what we are talking about. Okay. And then this function is going to return the user object to us so that the next function will have access to it. Okay. And then, so the next thing we're going to do, I'm going to pass a function to this. And then this function is going to fetch the let me just copy this and then okay. So for now, I'll just take this off. And then so let's see how this one goes. Okay. All right. So we've passed the callback function to this, but we did not handle it in here. Okay. So let's see. Callback. Okay. And then we can see. So after this is done, we can call our callback and then pass our user. Okay, our user and then the username to it. Okay. Please, if you are confused, kindly let me know. All right, let's test it one more time. Okay. So in our console here, let me clear console. So when I run this for 2 seconds, we are retrieving. After 2 seconds, we are retrieving the GitHub info for Isaac. Okay, so that's the chain. First, we fetch the data. The next, we fetch the GitHub info for that particular user. So just in one function, we have one here, and then we've handled the other one also in here. Now, the last one is to get all the repos for that particular user. Then with that, we have to define a callback within this function so that it will be handled in here as well. Okay. So down here, in this function, we need to declare another callback. Okay. And then this callback is going to callback. And then with this, we're going to pass the GitHub. So let's simulate that as well. So with this, you can see. We're declaring an object and see. Follow something. The profile. It's just so we're getting the profile, user profile, and then the username. We have the username already, so there's no need for this. Just that. and we can pass this. Let's pass this object. Okay, so it's all right. Callback. And okay. So we call, let me collapse this and then define another function for this. All right, I'm beginning to get confused. And that's the problem that comes with the callback. Okay, you end up nesting a whole lot of functions within each other. And as I said, we've not even gotten anywhere. And myself, I'm beginning to get confused. That is the problem with this particular approach. You end up messing up everything. And that is why we have other ways to handle this particular approach. Okay, so right now that myself, I'm confused, I'll move from here to the next one so that I'll not get confused. Else we have to close. Okay, so I'm just kidding. But in order not to get confused and then get our code bloated like what we've done now, we're going to move to the next one, which is so, all right. The named functions. I'll talk about callback health. Okay. So when we talk about, let me just give you a brief. When we talk about callback health, I mentioned that to solve this problem, we need to chain functions, callbacks, in order to get this particular process done. Okay. That is what is happening here now. We have our first function here, and then it takes the callback function. So we call it, we pass the callback to it this way. Okay, that is the first item. The second one also takes a callback, okay, which is also another function. And then we're going to use it in here. Okay, that is, we keep on chaining. So imagine we had another process. That means we are going to also add another callback within this same callback. So we end up nesting so many callbacks, and that is what we refer to as callbacks, callback hell. So when you have the term callback hell in JavaScript, you can talk of it as nesting callbacks within callbacks. That is callback hell, and it's hell because right now, as I said, I'm confused. I'm in a mess now. I don't know what I'm doing. Okay, and that is the problem that comes with callback. You end up having a callback hell. And that is where named function comes in. When we talk about named functions, even with this example, there is one in there, but we're just going to break it down so we all understand. What we mean by named function is that, let's see something here. Here, I'm passing an anonymous function as a callback to the get user data function. Okay. We can extract that anonymous function, create or define a different function for that callback, and then pass it into our get user data. With that, we have not changed anything, but it makes it cleaner compared to this particular approach. All right, so let me put that in action. So we have get user data, it takes a callback. Okay, so I'll come down here, and instead of passing this callback function to it, I'm going to cut everything. Okay, then I'm going to define get GitHub info. Thank you. Okay. I'm just going to paste what I copied. This here. I'm going to set timeout. Okay, so I've put it inside a new function, just like what I did earlier on here. Okay, and now I can pass this GitHub info to this function, just like that. Now take a look at some. I'm not invoking this function. I'm not calling it. Okay, I am not. The reason is with callbacks, you don't have to invoke it. Once the process in here is done, sorry about that. So once this process is done, automatically it's going to invoke the next function, the callback function. So it's not, you don't have to invoke it. Okay, so just pass it. A typical example, I'm sure you're aware of, is this function, this method in JavaScript. They call an element, and they will say, so let's say inputs dot and then add event listener. Please, how many of us are aware of this particular thing? If not, I should stop right now. Are we aware of this particular thing, event listener in JavaScript? Yeah. So with this, it takes a first argument, that is the event that you want to listen for. So example, click. So when I click on a button, what should happen? And then you pass in an anonymous function. Okay, like this. This second part is a callback function. Okay, so with that, you can decide not to write a function in here, and then define a function somewhere and then pass it in here. Okay, so this is going to be a function, but we don't invoke it inside here. Just pass a reference to that function, and then it's going to take control, then do what the necessary. So we get the user data, we pass the get info to it. Okay. So let's see something here. I'm going to run it. Let's see if we're not getting any error in here. Okay. So we are getting a. Okay, sorry. We have a callback in here. All right. We defined a call, sorry. So I'll take this one off for now. Yeah. So right now. Okay. So now we retrieve the user data and then we get the user info. So now we've extracted that callback function, we've placed it inside of another function, and we are passing a reference to it. With this, it's cleaner. So if we want to use, if we want another callback like we had earlier on, then we would just go ahead and pass it in here. So I'm going to see. So first I'm going to, the last one is to get the repos. Okay. We have a function in here. Then we're going to say set timeouts. Okay, so console.log, and then I'll see. Fetching repos. Okay. All right. So I want to ask a question. Now we have get user data. We've added this callback function to it. How can we pass the last function, which is the get repos, to this particular? How can we chain it, add it to this in order to get our repos? Anyone to help us with that? Anyone to help us with that? How do you think we can chain this get repos function to the user info here? I hope I'm not off the call.
No, you're not off the call, Isaac. So guys, you
Oh,
can go
okay.
ahead to reply or drop a message in the chat room so that he answers.
All right, that's fine. So what we're going to do now, I'll just take this one off. Okay, the username, because at this point we don't need it. Okay, and then I'll come down here. So now this get user function itself, it takes a callback. So I'm going to pass the get repos to it. So I'm going to make a reference to that. So I'll just sit on, let's just repo one. I'm just passing an array to it. One, two, that's fine. Let's run and see if you're not making any errors. Okay. 1, 2, 3. Callback. We are passing it in here. That's I'm making an error. User.username. Oh, okay. Sorry. Okay, that's because I changed it this way. All right. Okay. Okay. All right. Okay. So that's with callbacks, passing a function as an argument to another function. Okay. And that is one way. Everything that we're doing here, it's not clear, or it's not going to be clear until we get to the async await of the promises. And when you start applying or implementing them, when you were working with MongoDB, did you do anything? Did you use anything like await? Did you do anything like that?
Yes.
You used something like an await.
Yes.
Oh, okay. Okay, that's fine. So then if you did that, then let me use that. Let me also explain. I think that will help me with this part as well. So the reason why you're using the await, as I mentioned earlier during the explanation of the intro, it's a process that is going to access the disk. Okay, the database is stored on your hard drive, and we have to wait for the results. We need the results of that operation in order to continue with our work. So we have to await that process. Awaiting it means that we've given that event or that process we've left it in event queue, and then our thread is also handling that stuff. Once the request is ready, it sends it back to us. Okay. So a typical example in here. So let's say the DB call we're making at that time, it's going to take 2 seconds to return our data. That is what we've done here. Okay, so this set timeout is just simulating that process, that delay process, that small delay there. Okay, so it goes into a DB, fetches the user data and send it back as an object to you, and then it returns that user object. Okay, and that is how it's being done behind the scenes. All right, that is what I want you to understand. So now we've talked about callbacks. We've talked about callback health, that is chaining or having nested callbacks. And then we've seen how we can solve that callback health issue with named functions. So we extract our callbacks and then put them inside a named function. And then we pass the named functions as arguments to our other functions. And that is cleaner compared to the callback health. But it doesn't end there. Okay, there's a cleaner way to solve this, and that is what we call promise. And that is, it's a very important concept in JavaScript. Many people find it very difficult, but it's very easy. Okay, when we say promise, think of it as a real-world promise. It's not anything different from what we've been talking about. Promise. It's the normal thing. Okay, so this is how it works. Someone promises you, next week I'll give you this. From the moment the person promises you that particular thing until the time that the person delivers, it's called the pending state. You are waiting for that particular promise to be fulfilled. Okay, that promise is in the pending state. That is one. After the pending state, there are two other states. One is the fulfilled state. The other is the rejected state. The person who promised you can fail you. That's in programming we say, or in JavaScript, we term that as rejected. That promise has been rejected. Okay, it has failed. Then the other state is the fulfilled state. The person has acknowledged the promise. So I promise to give you this. Now the time has come, take it. That's the last state. So when it comes to promise in JavaScript, there are three states: the pending state, the fulfilled state, and then the rejected state. Okay, so let's see how we can use promises to solve this problem without having these long callbacks. Okay, so I will just, so we had 30 lines of code, that's fine. Yes, I'll just keep that in mind. So to declare or to create a promise, we can just create a constant, and then I would say get user data. Okay, it's a promise. And then I would say new promise. Okay, so it's inbuilt, it's in JavaScript. Okay, we have a promise class, and to create an instance of a class, you can use the new keyword. Okay, so when you do this, it creates a promise for you. So the type, IntelliSense is telling us the type of this data is a promise. It's a promise. Get user data is a promise. So I said three things are involved: the pending state, the rejected state, and then the fulfilled state. Okay, so to do that, to handle those states, then it has a callback to this function. Okay, so as I said, they're not different. They are just built up on callbacks, just that they are making it simpler and cleaner compared to the callback itself. Okay, but in here, it returns, I said that states, the fulfilled state and the rejected state. So here we call it resolve. Okay, we see once the promise is fulfilled, we say it has been resolved. Okay, so resolve. Then the last one is reject. Okay, so there are two states after. So once you run the program, the process is run, it's in a pending state. Once it's done, it's going to return either a resolved state or a rejected state. That's it. So I said resolve is for the positive one. That means the promise was fulfilled. Reject means it was not fulfilled. It failed. That's reject. Okay. And these two parameters or these two arguments or data that we are getting back, they are functions. This resolve is a function. Reject is also a function. So if there is an error or the process fails, you reject with a reason. So when I hover on this, okay, this part's okay. So up here you see parameter reject, and then inside we are asking for a reason. So if the promise fails, then there should be a reason why it failed. So mostly it's like the error message. Maybe you did not add the user ID. That's the reason why it's failing. That's the reason. And then there is the resolve parameter. If it resolves, there should be a value. Okay, so if the promise is fulfilled, it returns a value, what you requested for. If it fails, then you should get a reason why it is failing. It's as simple as that. And that is the basic idea behind promises. Okay, so I'll go over it again. To create a promise, you create an instance of the promise class using the new keyword, and then pass a callback function to it to get your return value. It could be fulfilled or rejected. If it's fulfilled, you use the resolve method, the function that is returned to you. If it fails, then you're going to use the rejected and reject parameter. That's or reject value that is returned to you. Okay. So I'll open it in here. So we are creating a promise. Okay, so we are going to resolve. So I said they are all functions. So you can see from here, resolve, and then we pass the value to it. So getting the user data, then we're going to say, we're going to pass the user object to it, the one we are doing earlier on. So the username, and then I'll pass Isaac to it again. Okay, all right. So this get user is a promise. Okay. Then I'll come down here and then I'll say get user data. And then I hover on this and you see it's a promise. Okay. So I can do dots. Now, I also mentioned how to consume promise, how to use it. When you create a promise, you should be able to consume it. Okay. There are two important methods that you need to take note of, and then they come with the promise. If a promise is fulfilled, that is, if it is resolved, from now I'm going to use resolve. If it is resolved, then there should be a value. That is why we have this then method here. If a promise is fulfilled, then there should be a value. So you should be able to grab the value from the then method. If it fails, that is, if it's rejected, then we need to catch the error. So in real world, let's say someone is owing you, you lend, you borrowed money to someone, and then the person failed to return the money. It's like, if the person returns the money, it's resolved. So then you take your money. If the person fails, then you catch the person and you go call police and you catch the person. So it's just something like that. So if it fails, and then you want to grab the error message or the reason, use the catch. If you want to get the value, use then. So I can say dot then. Okay. And so this is saying unfulfilled. It's going to return a value. So we can grab the value like this. Okay. And then you say, let's just log the value, console.log value. Okay. So let's try it. Okay. So down here we see it's returning the user object to us. Okay. To simulate one for the reject, I'm going to reject it instead of resolving. So I'm going to comment this line out, and then I'll say reject. I have to pass a reason. Okay. So this time, instead of, I'm going to create just a new error, and then I would say, so it's just an error message I'm creating. Does not match any record. Okay. So I'm not going to change that. Initially, I said it works if you want to catch the error. You need to use catch, but I'm not going to change it. I want us to see what happens. So reject, I'm using then here. I'll just run it like this. And then we are getting plenty errors. Okay. So in order to solve that, so we chain that, so we can do dot. So it's just a continuation of it. So dot then dot catch. Okay. So the same way we can just, so I can just grab the error message like this. Then I'll say console.log, and then I'll pass the error to it one more time. Let's see if we still get the error in our console or we are doing the right thing. So I'll just run it. Okay. Okay. So let me just pass. Okay. All right. Okay. So now let's see, we are getting our error message now in here. It's saying the user ID does not match any records. So that's with promise. You create a promise this way using a new keyword, and then you consume it using then and then dot catch. Any question before we move on so that we can apply it to what we've done in here? We are almost done. Any question on promise?
Hello guys, are we still here?
Yes, no question.
Okay, all right. So let's try and solve the problem up here with the promise. So I'm going to just take this one off. And instead of defining a constant like this, I'll take that off as well. Then okay. So this time I'm going to return and then I would say resolve. Okay. So we're just going to simulate something. So in here we are going to say user ID. Okay. So I would say if the user ID does not exist, then we're going to reject. If the ID does not exist, we're going to reject with a message and say okay, that's not much in the record. What else? Then we're going to resolve it. Okay. We're going to resolve with the user object. So I would say let's get the username. I'll say ID1. Okay. So it's just something I'm simulating. So we've created this particular function, and then the return type, if I hover on it, the return type is a promise. Okay, the return type of this function. So we've declared a function which is a promise. So in order to consume this particular function, we need to come down here and say get user data and then it needs the ID. So let's run this without passing the ID. Okay. So as I said, since a promise, we need to chain the then in order to get the answer. So the then, and we're going to get the value. Okay, so we can just log the value down here. So I can just say value. Okay. If it fails, then we can catch it. Okay. So error. Go ahead and say console.log error. Okay, so simple. All right. So I'm not passing the ID in here. So we should expect our program to fail because it expects if the ID does not exist, it should throw an error. Okay, let's see. All right, and then we've successfully gotten our error message. So the user, it's match. Okay, does not match any record. Okay, so if we go ahead and then we pass our value in here, so say 1, then we run, then we successfully get our user data. So that's it's resolved now. Okay, so that is how we work with promises. Okay, yeah. Any question regarding promises?
No question.
All right. So I mentioned that there is another one called async await, and I think with that you mentioned that you've used it before. That is during your MongoDB class or session. It's nothing different from what we just did. It's a promise. It's just like it's a sugar-coated promise. Okay. Even though I said this particular approach is cleaner compared to the callback, the async await approach is far cleaner than this one. The async await method or approach helps or allows you to write your code just like you're writing synchronous code, so in that order, but it's asynchronous. that is it. So JavaScript, they sat down and they realized now we can just make it better. Okay, so let's try hands on it, and then we will understand it better. So I'm going to clear what we have in here. So first we're going to get our user. Sorry, can you follow for me? All right, so get user data. Okay, and then you can see user ID something. All right, so we have a function in here. This function it's in itself synchronous. Okay, so in ES6 or in a new JavaScript, they've introduced a new feature called async, that is asynchronous, like so, asynchronous. When you do this, when you put this keyword in front of your function, it makes it asynchronous. So to just think of everything we've talked about, like the set timeout function, like what we've been doing, it makes your program asynchronous. So if you run this function and it's going to access the network or the disk, and then the data is delaying, your program is not going to overlook it. It's going to keep this in the event queue. Once the result is ready, it's going to send it back for you to use it. That is the power of this async keyword. Another thing to take note of, when I hover on the function name, look at the return type. It's a promise. Okay, we just talked about promise. We've not done anything. We've not used any keyword here. We've not created a new class or a new object using the promise class. But using the async keyword, it makes our function a promise. Okay, so we can call get user data and then use dots and then catch. Because we use the async keyword, it has converted our function into a promise for us. That is the beauty of async await. It makes you write your code cleaner, and then it's way cleaner than what we had earlier on. Okay, so that's async await. Then I've been saying async await, async await, async await. Where is the await? Now, if you want to call another process, okay. So let's say we get GitHub info. Okay. So console.log. Console.log. Let's just log something on the console. Okay. All right. So to get the user info, so just move this up here, and then we're going to call this get GitHub info in here. Okay. So this particular operation is also going to access the network, and so we need to decorate it with the await keyword up here. Okay. And what this does is that, sorry, let me just, okay. What this does is that this particular gets GitHub info, it's in itself, it's a promise because we have the async keyword here. So every operation that will go on here, this process is going to wait for the result of it and then use it for the next process. It's not going to overlook it, it's going to wait for it. Okay. And then I could have done this outside here and then just get rid of what we have here. But it is a rule. It's a rule in JavaScript. You can't use the await keyword outside of an async function. So what we've done here is syntactically wrong. We can't do this. This is an async function. This is the await keyword. We are using it outside. It's on its own, and that's going to throw an error. Okay. And so anytime you want to use the await keyword, it has to be inside of an async function. So we need to get the GitHub user info after we've gotten the get user data. So we need to move this line inside of the async, async function. So now we've obeyed the rules. The await keyword has been used inside of an async function. Okay, so now we are waiting for this process, and then you can grab the user ID from here. Okay, so let's run and let's see what happens. First, let's assume it's going to return the data for us. So I'll just declare user. Okay, and I'm going to pass the user to this function so that we can grab it from here. So I would say user dot username Hope no one is confused. This is the string template literal approach. I just want to. So when I run this, I should be able to see hello Isaac on the console. Let's try it. Okay. Need to invoke it. Get user data. Then I'll pass my ID to it. Okay. And then let's run again. So in the console here, I'm seeing hello Isaac. Okay. So I get the user with the ID. It gets me this user object, and then I pass it to the GitHub info down here. Okay. And then it's returned in this function for me. So things that we need to take note of. You can't use the await keyword outside of an async function. It should always be used inside of an async function. Okay, so it might be like this particular function that we are working with, the get user data function. We are not waiting for that particular function, but because we are using the await keyword inside, then we need to create that function with the async keyword. Another thing to take note of, when you use the async keyword on a function, it becomes a promise, and so you can grab the value using the .then and then .catch value. Okay, there's another thing that I have to talk to you about. Okay, so one thing that you're not asking me questions, so I'm asking the question myself, and then I'm answering them. All right, that was just by the way. So when we are working with the promise approach, I mentioned that if you want to catch errors, you need to use .catch. If you want to get the value, you use .then. Okay, and then I also mentioned that since this is an asynchronous function, we can just go ahead and then, if you don't want to use the await, you can just get GitHub info, pass the objects we need to it, and then use .then and then .catch. Okay, since it is a promise. But as I mentioned earlier on, we are using this approach because we want to get rid of this chain. Imagine we have 5 different asynchronous functions operations within this. We are going to have .then, like we can chain it and then move on to the next one, because we want, so it can continue forever and ever until we get to the last one and say, okay, we are tired, it's okay, catch. Okay, and it becomes ugly once it becomes many. And so when you're using the async keyword and then the await keyword, you don't catch errors and then you don't grab the value with this approach. Okay, this is wrong. It will work, but it is not right. Let me put it that way. I shouldn't say it's wrong. So this is how we do it. To grab the value of an async or a promise using the async await style, we grab, since it's going to return the value, then we save the value to a variable. Mostly we use a constant because it's not going to change. So I can say this is going to return the GitHub info. So I would say GitHub info. Okay, so this GitHub info is going to store the value of the return, the particular promise. Okay, so instead of console login, I'm going to return the value, return the GitHub info. I'm going to return the user profile. Let's call the some API again, just something. /200, that's fine. And we have the username already in the user. So let's see what we have inside of this. So let's log it on the console. Console.log, and I can just go ahead and then do this. So I'll run now And then if we check the console, we are seeing our user profile, which is from this particular GitHub info function, okay, which is a promise. Now, I want us to take a look at something. I'm going to get rid of this await keyword. Let's see what we're going to get inside of this particular function. Okay, so I'll run again. Now, let's see the outcome here. It says it's a promise that is going to return this. Okay, what this means is that this particular result is the pending state of the promise. That is why we still have the promise keyword in front of it. So it's saying that this particular function is a promise that is going to return this object, the object in here. Okay, that is the meaning. If you don't, so you can grab the value out of this. If we do this, user dot, okay, user profile. User profile. Type it out myself. Let's run again. And now we try to get the user profile value from that return type. It's saying it is undefined. It is undefined because when we got there, it's a promise, but we are not awaiting that promise. So it will skip it. It will treat it as it's not ready. That's the value. It's not ready. So I'm going. Okay. It will not wait for, it will not keep the event or that process in the event queue. But the moment you decorate it with the await keyword, okay, it will now place the process that gets GitHub info process in the event queue. Once the result is ready, it will go back for the results. It will not skip and then pick the undefined value. Okay, so when we run now, we should see the user profile instead of undefined. So don't forget, if you don't use the await keyword, you're always going to get an undefined return type or value. If you don't use the await keyword on the promise, you're going to get undefined. When you use the await keyword, it must be used within an async function. I hope that is clear. Okay, so we've treated the then. So this is how we treat the then in the async await method. Okay. Now the next question will be, how then do we catch errors? How do we catch errors? And then we are going to introduce another thing. I'm sure you are familiar with that as well. In most of the programming languages, we call it try catch. Okay, so we use the try catch block to grab errors. To catch errors. Okay, so with the try catch, it goes like this: try, and then you open your block or your braces, and then you use the catch. So it's a try catch block. This time we catch the error here, and then it goes this way. So we're going to try this process. So I'll move this whole block inside a try block. Okay, and then we catch the error here. So we say console.log error. So this is how we handle the error. So let's run again and see if we are not making any error. Okay, so we're getting our user profile. Let's simulate an error. Okay, so instead of returning this, I'm going to say I'm going to throw a new error. Something unexpected happened. Okay, let's see. So I'll run again, and we are getting an error. Okay, with our error message in here. So in order to make it clear, I'll just say error, dot message. Let's run again. Okay, so now you see we are having something unexpected happened. We've been able to catch the error. Okay, and if you get the right answer or the value we are expecting, it will return in the try block. So you try your code or the process. If it fails, you catch it with a catch block. And so that is it for asynchronous. I think that is all you need to know. In order to get it well, you need to practice. Okay, you need to practice. You need to practice. That is the key. Practice, practice, practice. So today we've talked about asynchronous JavaScript. We've looked at the difference between synchronous and asynchronous, the benefits that the synchronous architecture comes with. We looked at the metaphor of a restaurant where there is only one waiter serving all the tables. We compared that to Node.js and we saw the event queue. We saw the thread, that's a single thread, and we saw multiple requests coming in. And then we said there are 3 ways to handle asynchronous code in Node.js. We talked about callbacks, we talked about promises, we talked about async await. We talked of callback hell, where we realized that is when we nest multiple callbacks in order to get a result. We saw the problem with it, and so we used named functions to solve that problem. After named functions solved that problem, we're still having our code bloated with so many lines. So promise came in to solve that problem. And promise did well, but could not get us the result because it was still a bit complex. And so we tried that with the async await approach, which allows us to write our code as if we are writing or working in a synchronous environment. But behind the hood, it uses the synchronous architecture to run our program for us. So that is it for today. Any question before we call it a day?
So hello guys, if you have questions, please go ahead and ask so that Isaac can wrap up. If there are no questions, kindly then we can call it a night.
Question. Good evening.
Okay, Vendex, go ahead.
Thank you very much for the lesson so far. I really appreciate it. You have done a good job. Thank you very, very much. My question is coming as regard to callback.
Okay.
Now, when you started explaining callback, you actually used the set timer to simulate a synchronous, right?
Yeah.
My question is, assuming I'm using callback for a particular project I'm actually doing, and I want a particular function of my code to actually activity of which I'm using callback. Set to set my timer to be 2 seconds, which is 2000 milliseconds. Now, assuming in that code, I'm trying to fetch data from the from database. What if within that 2 seconds, my system is unable to fetch that data? Will the process still run with after that 2 seconds?
Okay. All right. So I want to reemphasize that the set timeout function I use, that is, you don't use that in real world. Like when you want to fetch data, you don't use the set timeout. I use the set timeout to let you understand how to simulate it exactly. So that is how it works. We can pass any time to the set timeout function. But I was trying to let you understand that even if you pass 1 out to it, it will still be in the event queue. And then once the results is ready, it will send the results back to you.